James.
Yeah, okay, that's cool.
We got most everybody in, James. I'll go ahead and start.
We have 13 people in at the moment.
Okay. Well, the key is for them to hear Dan and Martina's presentation. I'm just setting the stage. So let me go ahead and get started and welcome everybody to the Future South May webinar. I think this is the 8th or 10th in the series that we've been running since the latter part of last year. We've covered a number of different subjects today. What I'd like to focus on is the innovation that are going to be needed in order to get the world to a net zero economy. And the target is obviously set for 2050. So we'll talk a little bit about that. I'm going to try to set the stage a little bit. And then I have Dan Stewart from Verity CO2, who is doing some significant development and commercialization that will impact the CO2 emissions world. And also Martina Miotto from CellulaREvolution in Newcastle, who is working on things to mitigate a lot of the methane emissions that we got, but it has some other applications beyond that. So let me just begin to set the stage here a little bit about the fact that I just do. There we go. There we go. Okay. All right. Try that.
I think you're on your last slide, Don. So if you go back to the top, that should sort things out.
Well, it's not letting me progress them. Okay.
Don, on the left-hand side of your screen now in PowerPoint, scroll up and click slide 1. Now hit start your presentation now. And now try.
Yes. Okay, there we go. Sorry. Obviously, the net zero economy target is not going to be easy. We can't wave a magic wand or fire a silver bullet that in and of itself is going to accomplish all of the changes that are going to be necessary to get to the net zero economy. And it is going to take a lot of hard work and a lot of change. Conservation obviously is something that all of us have to do, and I know that everyone is really trying hard to get their conservation of many things under control. But it's also taking a lot, and it's going to take a lot of changes of our habits and our practices. This is not going to be that easy. The other thing which Future South and Cleantech South have been working on for a decade or more now is to accelerate the adoption of green technologies to move, again, in further development of this net zero target that we have. But a lot of new innovations are definitely going to be necessary. Earlier this year, Bill Gates put out his book on how to avoid the climate disaster. And in there, he laid out a lot of things. But what I found quite interesting in his book was the little pie chart that's over on this graph, which says, where are the greenhouse gas emissions coming from? And the key there is that it's things that we make, it's energy that we use by plugging in, it's agriculture and things that we grow, it's transportation and getting around, and it's keeping our buildings in climate control in our buildings. And those are all quite significant emitters of gas, of both methane, CO2, and other types of greenhouse gases. In addition to his book, also there's been three other major reports released relatively recently. UKRI, and particularly the Energy Catapult, put out their innovating to net zero a few months ago. And of course, they talk quite a bit about new technologies that are coming along. I believe it was last week or the week before that the International Energy Agency put out its roadmap to net zero by 2050. And in there, they talked about the fact that over half of the technologies that are going to be needed are still at a very early stage. And then earlier this week on Monday, I think it was, CBI put out their Seizing the Moment strategy for the UK economy, and it talked heavily about decarbonization and, of course, innovation. I don't know how many of you on Sunday mornings watch the Andrew Marr show, but I watch it fairly regularly. And week before last, Sunday before last, he had John Kerry on, who's the U.S. climate envoy, and he'll be here, I'm sure, for the COP26 activities later this year. But in that interview, he talked about the fact that, and Andrew pushed him on this, and he talked about the fact that that over 50% of the gains that we're going to need to have between now and 2050 are from technologies that we don't have yet. All of this made me think about the fact that I'm from this little country town in Texas, okay, Eagle Lake. And it's, for a small town, it had a very diversified economy. It was one of the biggest rice growing areas in Texas, had a lot of cattle breeding and growing there. We dug a lot of gravel and sand for concrete. In fact, most of Houston is built out of the sand and gravel that came from the area. And of course, we had oil. And as I was preparing for this webinar, I got to thinking about that in the things that we grow, of course, cattle and the methane emissions that they have are significant. But I was quite amazed to realize that rice growing was one of the major crop growing generators of methane gas. Of course, concrete and cement are a big CO2 emitter, and it goes without saying that the petrochemical industry. So it really drove home to me that in the little country town that I grew up in and came from, they're going to have to do some significant changes that are going to have immense impacts upon their economy. Even though it's a quite diversified economy, it is all greenhouse gas emitting economies. So with that, the other thing that we've got to do is we've got to make a start. And amazingly, over the last year or so, during the pandemic, we've had a 7% decline in the CO2 emissions. Now, this has required us to change, as I talked about earlier, change our habits and our practices quite significantly. And we have done that, not because we particularly wanted to, but because the pandemic forced us into doing that. And that has resulted in a 6.7 or nearly 7% reduction. The key is that's a great start on the downward curve that we need to have. And the real question is, can we continue it? And I think it's going to take, as we talked about, a lot of innovation. So with that, I'd like to first turn it over to Dan to talk about some of the stuff that he's developed in the group at the University of Southampton Chemistry Department to do things on CO2 capture and emission and capturing the emissions and dealing with it. And then after that will be Martina from the University of Newcastle that has done significant development there on cell replication. So with that, Dan, I'm going to relinquish the screen to you.
Everybody, thanks, Don. And thanks very much to the Future South team for inviting me on. It's nice to be here and be able to share with everybody what we're trying to do here at Viridi CO2. So yeah, my name is Daniel Stewart, and I am the co-founder and CEO of Viridi CO2. For anybody who is wondering why we call ourselves Viridi CO2, I thought it was pretty obvious when I came up with the name, but Viridi stems from the Latin for green, green CO2, and that's very much sort of the heart of what we're trying to do. Currently, we are in the position of imminently spinning out from the University of Southampton, and our ultimate aim is to enable chemical manufacturers to transform carbon dioxide into high-value chemical products, reducing their fossil fuel reliance, reducing their CO2 emissions. I'm very sorry, someone I think is fitting a bathroom above us. In order to increase the chemical industry's sustainability and to close the carbon loop. So today I'll tell you a little bit about how we kind of got to where we are and what we're trying to do. So Viridi CO2 was actually conceived during my PhD studies. I finished my PhD last year, started in 2016, and the PhD was conducted at the School of Chemistry at the University of Southampton under the supervision of Professor Robert Raja, who is co-inventor and co-founder of Viridi CO2. When I sat down for my PhD interview with Robert, we decided that we were going to try and do something really easy, in that we were going to try and tackle carbon dioxide. As I told him quite bluntly that I wanted to do something that was actually worthwhile and not doing something in science for the sake of science, which you'd be surprised how many PhDs are actually based upon. And we decided on an ambitious project where we design catalysts that are capable of transforming carbon dioxide in order to improve current industrial processes. The catalysts that we make are heterogeneous. What that means for the layman is that they're solids in a liquid or gas medium. Hetero, they are different in phase to the reactants. This is different to a homogeneous catalyst, which is in the same phase. The key distinction here is trying to separate a catalyst, which is a solid, is really easy compared to a liquid. So the example I like to use is removing sand from water, really, really easy. Trying to remove orange squash from water, really, really difficult. I'm a chemist, and I'm not even entirely sure how I'd go about that to begin with. But anyway, I spent 3.5 years developing these catalysts, and about 6 months into the project, we found something that we thought was gonna work. Something that was far better than any other method we've seen in the literature or in the market, and we decided we'd run with it. So partway through the PhD, we got involved with Future Worlds. That's the on-campus entrepreneurial unit who brought us to our business advisor, who's actually appeared on the call, Chris Spackman. And with Chris, Robert and I, we decided to start developing what our offering would be as a company. This took us into the Set Squared iCure scheme, where we met Don, and we validated the market over 3 months to try and understand whether actually the chemical industry and beyond actually wanted this technology. And we were pleased to report that it was. And within this journey, we've had sort of developed a number of links and won various accolades, one of which we're really proud of is we won the Royal Society of Chemistry's Emerging Technology competition last year in the energy and environment sector. So that's a little intro into Viridi CO2. And now I want to focus a little bit more on what we're really trying to do. And Don highlighted Bill Gates's book. This is completely accidental. Don didn't tee me up for this. And the caveat with all of this is my business model was established before Bill Gates's book came out. So I haven't nicked his ideas. But in the book, Bill points out very clearly that to stop global warming and avoid the worst effects of climate change, humans need to stop adding greenhouse gases to the atmosphere. And that very much lies at the heart of Viridi CO2. For those who haven't read the book, just a little spoiler alert, Bill Gates touches on the 3 major industries that need to get cleaner. They fall under the 31% of making things, cement, steel, and plastics. And we hit all of those within our business model and approach. So there are 51 billion tons of CO2 equivalents being released every year. And this is the first problem that we aim to tackle. We're not going to do all 51 billion, unfortunately, but where we first aim to make improvements is within the chemical manufacturing industry. The chemical manufacturing industry, combined with petrochemicals, is actually responsible for 6% of all emissions. In total, in 2016, it was 880 million tons of CO2 alone. This doesn't even begin to touch on the other industries that are huge polluters, such as cement, steel, and iron, which is then responsible for another 10%. The second problem we are touching on is that chemicals are produced solely, pretty much, from fossil fuels. Depending on where you read around, fossil fuels are only going to be around for about 50 years more based on current consumption rates. There are arguments that there are more fossil fuels, just deeper in harder to reach places, but ultimately that would hike the price of fossil fuels. So there's a real impetus to move away from them in order to increase sustainability of these chemical processes. So really, there is a very simple solution here, and that is, why don't we utilize the waste CO2 that comes from these manufacturing processes and replace the fossil fuels with that CO2? In order to do this, you actually need a catalyst, and this is where ViridiCO2 truly adds value. What we are allowing is chemical manufacturers to redirect waste CO2 emissions. So we're not a capture technology, that's really important. We are the utilization technology, but we allow the CO2 emitters to redirect CO2 emissions into chemical processes, directly replacing fossil fuels using our technology to make high value chemicals. In doing so, we actually make chemical manufacturing safer, faster, and more sustainable. That's because our technology actually facilitates much lower temperatures and pressures than more traditional chemical manufacturing methods, and certainly a lot lower temperatures and pressures than a lot of the competition use in order to furnish CO2-based chemicals. To date, ViridiCO2 has 2 patents filed, and we are looking to go to national phase fairly shortly. But this technology enables chemical manufacturers to use a solid, a heterogeneous catalyst to make high value chemicals, separate it very easily from those products, and then actually reuse it. So ultimately, the solution we're providing is cheaper and more widely applicable to a number of chemical processes than a lot of technologies already out there. So, been making a lot of very bold claims up to now, and I like to be able to substantiate them somewhat. The main area that we're going to look to penetrate first is polyurethanes. Now, for those of you who don't know, there's about 400 million tons of plastics made a year. 30 million tons of those are polyurethanes, 4 million tons in Europe alone. And this is a plastic that is the least recycled plastic of all. Polyurethanes actually rely on being either mechanically recycled, end up being incinerated for energy recovery, or go to landfill. Now, one of the things that putting CO2 into these polymers allows is introducing a group, which you'll see here highlighted in green, that's CO2 inserted into our polymer, and that allows the chemical recycling of these polymers. That allows a point within the chemical which allows it to be broken down under certain conditions. And that allows the plastics, the polyurethanes, to be transitioned into a circular economy. So these kind of materials are called polyols. It's an 18 billion pound industry. It's growing very rapidly. And if by penetrating into this market, which has only been penetrated by less than 0.1% by the competitors, owing to sort of weaknesses in their technology, we're actually able to reduce fossil fuel dependency of the plastic industry by 20%. This product alone would result in savings of 10 million tons of CO2 a year, and whilst transitioning it into a circular economy. But what's really great about our technology, and where we hope we were able to grow our technology, is we can go a lot further than polyols. We're actually able, because of the nature of our technology and the way that we can chop and change bits very easily, is we can produce other high value chemicals. For example, battery electrolytes. The battery industry is growing, they all need electrolytes. Monomers, so not necessarily the polymers, but the feedstock material that can go into other polymers. And things like clothing fibers, such as nylons. Nylons itself is a 21 billion pound industry. Ultimately, the goal of ViridiCO2 is to decarbonize cement and steel. These industries pay 2 to 3% of their entire revenue on CO2 tax. The EU steel's tax bill last year was £800 million. So there's a real opportunity here to use their CO2 to make high value products. So where we are now, just to close and give you an idea of where we're heading, is we're currently sat at milestone 1. I am preparing everything to spin out and start on an Innovate UK grant. We won £300,000 from Innovate UK in order to scale up this technology in readiness of doing commercial pilots within 12 to 18 months with chemical manufacturers. So we've got quite an ambitious project ahead of us. I'm building the team. We've just taken on £600,000 worth of equity investment. And this will hopefully set us up for a Series A round in 12 to 18 months, where we can grow the in-house R&D team, application expansion, and go to commercial pilot. So with that, I'd like to thank everyone for their attention. I'm happy to take any questions, but I'd just like to leave you with the one final comment, is that without meaningful CO2 utilization, not storage, utilization, we will not reach net zero by 2050. So thank you very much.
Okay, and if we can turn it over to Martina, and you're on mute now, you're off. Good.
Yeah, perfect. Okay, perfect. So good morning, everyone, and thanks again for Future South and Dawn for the invitation to talk here today. So I'm Martina Miotto. I'm the co-founder and CSO of CellulaREvolution. CellulaREvolution is a spin-out company from Newcastle University. We spun out in 2019. After also, participating to the ICURE project as well, and then having some support from Innovate UK and from the RSC Enterprise Fellowship in Edinburgh. So what we are doing is that we are aiming at becoming the leader in continuous cell culturing technologies. So we are developing a new type of bioreactor, and this bioreactor will be useful for all those markets that are growing high number of adherent cells. So I would like to talk a bit about cultured meat, because this is one of the markets that we are tackling, that our technology will be useful to them. And I would also again like to talk about that, because that per se is actually an innovation that will have a lot of impact on climate change and greenhouse gases emission. So again, why talking about meat? As I said, well, we also heard from Don before, when he was saying that there are a lot of intense farming and cattle in Texas, and it's like that in other parts of the world. And the impact of this intense farming is really striking. If you want to just to have a bit of an idea about how much we are talking about, if we combine all the greenhouse emissions from the transportation sectors, so combining, planes, trains, cars, so all the traffic in the world, we are reaching about 13% of the greenhouse gases, and cattle is actually 5% higher than that. And looking a bit more in details, again, the breakdown of that 18% contribution mostly comes from the feed production and processes. So all the crops that are then, grown to then feed all the cattle. And then of course the cows digestion, that, as we are well aware, they are producing high levels of methane. Another interesting figures that is reported in the graph A, and in that study that was published in Science in 2018, is that if we have a look about the production of different food types and the greenhouse gases that are produced for that, of course, the animal source food are contributing the most, and especially red meat, as you can clearly see. And if we want to do a prediction of how these levels will change over time, of course, these are going to increase, mainly for two different reasons. The reason number one is because the global population is growing, reaching a forecasted 10 billion people by 2050. And also, we are well aware that the appetite for meat is actually growing. So more people are eating more meat. So, and also if we want to have a look at, in particular about the climate change, so the impact that they have on warming, as you can see in the drawing of that cow, climate change is quite a big chunk of it. And it's also important to understand what's the contribution of all the three major gases to the global warming. So we have, of course, methane, nitrous oxide, and carbon dioxide, do have different impact because they are retained for different length of times in the atmosphere. So, for example, methane, as you can see, if we are assuming that we are producing over time the same level of methane, we have an increase in the first couple of decades, and then that level will stabilize because, again, is not retained for that long in the atmosphere. That is not the case, unfortunately, for carbon dioxide and nitrous oxide that are constantly increasing and accumulating in the atmosphere. But overall, that means that even if we keep producing the same levels as we are producing now, as you see in the total line, the impact will keep increasing over time. So the only way to go down is actually to reduce the amount of greenhouse gases that we are producing. So what can we do about it? Well, someone would say, let's just stop eating meat, become vegetarian or vegan, or try to reduce the meat consumption as much as possible. That is true, is something we can do. But as we know, meat is, is good. Most of the people like meat, and also culturally, especially in our, in Europe and also in the US, we have this kind of long tradition of eating meat, as also as a social kind of way of staying together. So in order to kind of being able to help, let's say, meat lovers, but also helping our planet at the same time, one way of doing so is via cultured meat. So with cultured meat, what I mean is producing meat in a lab environment. And how does this work? You can see in that kind of yellow background image. So a biopsy, a sample is taken from the animal that is then expanded in vitro, usually in what are called bioreactors. So they are kind of big vats where the cells have all the nutrients to be able to grow. And then all these cells are combined to form the final product, which in the end will have the same characteristics as normal meat. And the benefits of these products are definitely on the environment. Again, we're not going to have intense farming, so we are addressing the issue that I was talking about before in terms of not only greenhouse gases, but also other things like, for example, deforestation, because the more feedstocks that have to be, crops that have to be produced to feed then the animals, that has also huge impacts on deforestation as well. We have health. And why that? Well, mainly because with COVID, we are well aware about disease transmission between animal and human, and that will be definitely not be relevant at all if this is produced instead in a lab. And also, of course, another thing that we are well aware is the abuse or intensive use, as you prefer, of antibiotics in animal farming. And instead, in cultured meat, one thing that we really want to avoid is to use any antibiotic during the cell growth process. Then, of course, we are addressing other issues such as the animal welfare, ethically, the conditions in which most of the animals are farmed are not optimal, let's say. And so, of course, in cultured meat, that will not be a problem anymore. And then ultimately the economies as well, in terms of trying to reduce food poverty, being able to make meat available for everyone, also in the countries that at the moment are not capable of doing so. And then again, as I said, for people that are not familiar with this, I really would like to have, some people reading about this. So giving a bit more of information on what kind of stage these industries, because some people might say it looks very like kind of a sci-fi or fantascientific thing, about growing meat in these big vats and then having people eating instead of eating animals directly. So there are a lot of startups that are at different stages, and this is the situation as it was in 2020 in a good report that was published by the Good Food Institute, which is an American no-profit organization that is promoting plant-based and cultured meat as well. And again, the industry is still quite early stage. Most of the companies started around 2015 after the proof of concept. Let's say the first cultured meat burger was produced by Professor Mark Post in Maastricht in 2013. And then from there, his startup started, which is called Mosa Meat, and then other startups, especially in the US, started to set up and working actively on cultured meat. So these companies that started in the beginning, they are at the moment starting as a pilot, it's pilot scale to demonstrate the first industrial-like production of cultured meat, producing about 100 of metric tons of meat towards the end of next year. Another milestone that was hit by this field last year was the approval from the regulatory body in Singapore to sell in a restaurant, which was this IT80, as you can see the bill over there. And they were able to get this regulatory approval in Singapore, and the company that produced these cultured chicken bites is called Eat Just, which is a startup that started in San Francisco in 2015, and they started initially making some plant-based products, and they also entered the cultured meat field a couple of years ago. And the commercial landscape, as I was mentioning before, the first one started in 2015, and then as you can see, more and more companies are joining this very exciting and impactful field. And along with that, also the investments are really, really increasing. In the first graph, as you can see, plant-based still is getting the bigger chunk of the investment, and this makes sense also because plant-based is more advanced on the technological perspective, so it makes sense that there is still a gap between the investment that is made in plant-based compared to cultivated, and it's called here, so cultured meat. However, in 2020, as you can see, there is being, and especially because of the COVID and knowing what are the benefits in avoiding another pandemic if we are implementing cultured meat and plant-based food and reducing the animal meat consumption, really there's been a huge amount of investment arising in 2020. But now, just a couple of slides to say about what we do at CellulaREvolution. So I hope that I kind of convinced you that not only cultured meat is important for the environment, but also that if we want to feed people with this alternative meat, we really have to produce a lot of cells. Again, we are growing cells that then will go in the final product. And if we want to, again, feed everyone, at the moment, with cultured meat, we need to generate about 10 to the 21 cells per year. This is really a ginormous number, which I tried to kind of make my head around it, how much that will be. And you could think about the number of grains of sand on our planet, or the number of stars in the observable universe. So we are really talking about a huge, huge challenge. So the way that people are doing that at the moment to grow all these cells, it's using a batch-based system where you put some cells in a big vat and then you wait until all that vat is full, is completely filled. up, and then you harvest all the cells out of it. But this is not an efficient process, and it's not going to be possible to use this type of approach to generate such a huge number of cells. A way to be able to do that is using a continuous process, where you have cells that are constantly being generated and creating empty space for other cells to grow into that big vat. And so in that way, we'll be able to address the scale-up challenge. And as I was mentioning before, this technology, this kind of switch between batch to continuous, is applicable to all industries that are growing high number of adherent cells. So cultured meat is, of course, our first target market that also has the biggest need and challenge. But we're also talking about industries such as cell and gene therapy, biologics, and artificial blood. So the benefits of these technologies are also relevant as a kind of environmental impact that they might have, because as continuous processes, again, are not a new concept. A lot of industries have been switching from batch to continuous during the last decades. And we're talking about oil and gas industry, just to make some example, but they've never been translated to this particular application because there was no technology that was allowing to apply this concept to the manufacture of adherent cells. And what at CellulaREvolution we have is a technology that does allow to apply this concept to this particular application. And as we know, benefits of continuous processes are, first of all, reducing drastically the footprint of the equipment that you need to generate the same output compared to batch. And also they tend to have an 80% reduction in resources that are required to produce, again, the same amount of product. And these two in particular combined, they will definitely have an environmental impact, which is really worth highlighting. And then in general, the system that we are generating, it will be also closed and automated to guarantee the quality of the product, and also to limit even more the amount of personnel that is required to ensure sterility. And as an extra QA actually control that a system like this will allow to have is a single cell inline QA. So every cell that is coming out of the reactor could be approved for quality assurance, instead of taking a single sample and assuming that that is representative of the whole batch as it is currently done. So I know the presentation kind of got a bit of what we do and also a bit of cultured meat, but that is, I think, because we are ultimately I would say a clean innovation to also make a clean product. So I wanted really to highlight not only what we do, but also the benefit of cultured meat. And I hope I made you also a bit curious of reading a bit more about cultured meat. And if you have, any question, I'm here and happy to answer. Thank you very much for your attention.
Thank you, Martina and Dan. And I would like to now kind of open it up to discussion and questions. I think we've covered some of the innovations, and I think that you should get a perception from this that it is going to take a little while for these to occur, but it is the type of thing that we need to have more and more and more of if we are ever going to accomplish the objective of getting to the net zero economy by 2050, or if we can get some significant approaches to that even before. So does anybody have any questions for Martina or Dan? My comment is, of course, and I have tried in Singapore the cellular produced meat, and I've got to admit, it's not quite the same yet as eating a steak that's sliced off of a beef carcass, but it is certainly a much better approach than some of the meat substitutes that come off of using vegetable products. So I think it's going to take all of these to get there.
I was just going to say the exact same thing, Don. When I was in Singapore, I tried the, I think they're called Beyond Burgers.
Yep.
And they're the ones that bleed when you cut into them, which is a nice feature, I suppose. But yeah, the texture just wasn't quite right for me. The flavour was good, and I'm sure, you know, working with that formulation, then, you know, it won't be long before be able to blind test me, and I won't know the difference.
These are your challenges, Martina. Okay.
If you can please a Texan, then you're probably onto the right thing there, Martina. Let's face it.
That's a very
Yeah, the Beyond Burger, it's still a plant-based product. The chicken nuggets that I was talking about that were approved in Singapore, they have about 1% of cells, and the remaining 99, it's still plant-based scaffold. So I think it's important because of the regulatory approval. It means that they approve to have cells in a product that then is for approved, let's say, for meat, for human consumption. But in terms of percentages, again, of cells that are in there, is still very, very low. I'm not sure you can really tell the difference between a plant-based nugget and the one that was produced by Aegis, but I haven't tried it, so I can't say for sure.
Just, can I jump in, because there's a question that's come through on the chat from Bob, just before, because there's a couple of people with hands up as well. Bob, where does the CO2 we use come from? Is it from the atmosphere or a chemical process somehow? We don't directly capture CO2 from the atmosphere. We're not a direct air capture company. What we do is redirect existing CO2 emissions. So every big chemical manufacturing site will have a power plant. That power plant powers the entire site, and that has a lot of CO2 emissions associated with it. So what we would look to do, admittedly not at the stage we're at now, but in future, we would look to sort of funnel those emissions into a CO2 stream, which can then be put into the process. So at the moment, we're operating out of CO2 cylinders. We'll transition into CO2 streams based on who the customer is, what the CO2 stream is, how pure it is, whether we need to do any kind of purification processes. For that, we've looked to partner with people who are able to do that. I emphasize sort of in the presentation that we are the utilization step. There's a lot of people in the carbon capture market. It's quite a crowded space, whereas the utilization space is pretty wide open at the moment. So I hope that clarifies your question.
Brilliant. So a question we had for Don was, how do we maintain the working from home lifestyle after the pandemic?
That, I think, is going to be a very big challenge. Okay. I mean, I am monitoring any type of data that I can to see as we move out of the pandemic lockup situations that we've had, and are people going to go back? I mean, a lot of the things that I haven't probably used up more than about 2 or 3 tanks of gasoline in my car in the last year. Okay. And, you know, and I'm sure that I'm not unique in that. There's going to be a lot of other people that haven't. Is that going to change? And we know that it will, but how much is it going to change? And I liken it a little bit to the concept of the rubber band. We have clearly stretched a rubber band in many different ways and in many different formats over the pandemic situation to be quite different than what the state was before the pandemic hit. Once the pandemic releases things, it will move back. But I do believe that it will not move back all the way. So in that graph that I showed, which is CO2 emissions dropping nearly 7%, I suspect that it will not be a continuing 7%. And in fact, I suspect that we will actually see some pullback. But how much is, I think, going to be up to a lot of the way people look at how we're going to do it. And I think that's one reason why it's very timely now to put a huge amount of effort into the fact that people have had to make quite radical changes in many ways to their lives. And I think we need to emphasize to them that that has actually made a major accomplishment in our efforts to get to a net zero type of an economy. And we cannot just completely regress. We must do that. And then the other thing, which is, of course, the subject of this webinar, is we're going to have new technologies that will allow people, because as much as we want to conserve, as much as we want to change our practices, we're not going to go back to being hunter-gatherers, okay? That's not going to happen. And we're going to have to continually provide a type of culture and society that we've become accustomed to some degree. Which changes, no doubt, we must make those, but we're not going to sacrifice, the world around is not going to sacrifice. As Martina said in her presentation, the consumption of meat has continued to go up quite substantially. And a big part of that is as the economics of many parts of the world that have been on very low economics increase, the amount of desire and need and to have meat is going to increase. So we've got to understand that concept, and we've got to be able to have the technology innovations there to in order to provide that to people to maintain the desires that they want to have in their lives. So this is a huge challenge, and that's the reason why I think my first slide emphasized we've got to approach this from so many different directions.
Yes. So I saw that Peter and Chris, you put your hands up. I think Peter, you were the first. So do you have a question?
Okay, thank you. So a question for Dan. First of all, well, congratulations on getting this far with your iCure program, and indeed securing the Innovate UK grant and the other equity funding. It's a fantastic achievement, and the very best of luck with it. So I suppose the question, Dan, is, I mean, you mentioned there your technology and the catalyst that you have. Are there competing catalysts out there already doing this? And is it a case that your catalyst is better in terms of being safer and faster, cheaper, and is that the advantage? Is there anything else out in the market already doing this?
That's a fantastic question, because it gives me a real opportunity to plug our technology even more. Yeah, ultimately we have three key competitors in the market at the moment. One is Covestro. Covestro is by far the leader globally for CO2 produced chemicals. The second is a UK-based company called Econic. They've started out sort of 2013 out of Imperial. They're doing remarkable things as well. And then the third is Saudi Aramco. They're kind of flying under the radar at the moment. They bought the CO2-based polymers from Novema, which are a US-based company. Econic and Saudi Aramco use the liquid catalysts, the homogeneous catalysts. So there's great expense and time spent on removing the catalyst from the products afterwards. And I have it on good authority from a couple of chemical manufacturers who I've spoken to already that say that actually having the catalyst left in there, even in a very tiny amount, compromises the quality of the product. So naturally they can't use them. Covestro use a solid state catalyst, but in order to stick CO2 into these polymers, they require 90 atmospheres of CO2 and 130 degrees Celsius. 90 atmospheres is the equivalent of being a kilometer under the sea, that kind of pressure. We can do it under 5 atmospheres of pressure and 45 degrees Celsius. So the energy saving is huge. But in addition to that, there's capital savings as well. You imagine you have to build a plant that can handle 90 atmospheres of pressure. You don't have to build to that level of strength for anything that handles our processes. So the capital saving is huge also. So that's sort of the main.
Yeah. That's very interesting, as I suspected. And just one final question. I mean, you focused there on the polymer industry, and the cement industry is producing a lot of CO2. I used to work many years ago in the chemical industry, the fine chemical manufacturing industry as a chemical engineer in Ireland here. And there's a lot of the big pharma companies producing, when we talk about pharma companies, they're really fine chemical manufacturing companies producing the active ingredient. And of the top 10 in the world at one stage, there were maybe 7 or 8 of them, still are, with manufacturing bases in Ireland. So I'm just wondering, is that an area you've looked at, or there are opportunities to do something with that industry? I don't know.
So ultimately, yes, it's the same business model as we would take forward to apply to steel, cement, and iron. So those industries, we don't directly make the product that they want to make. So we're not making steel girders, but what we're doing is utilizing their emissions to then put it into something else. So with pharma, that would be the same business model. They would have a power plant, GSK would have that on base. We take their CO2 emissions and put it into a product that is desirable to them. What that product is, that would be very dependent on how a project with them would look, but it's just a slight tweak of the business model. And yes, ultimately, we would target those guys as well.
Okay, thank you.
I think that the other thing to just an adding to that is that there's a huge amount of investment going into capture and storage, and that's good. But I think that if you do the calculations, and Dan's probably done these or seen them done, is that we don't have enough storage places to store as much as, so we do have to find, as Dan's stuff doing, reuses of that CO2 as much as we possibly can.
Absolutely. And actually, there was a report that was released by the BEIS, and 168 million pounds of taxpayer money has been put into storage solutions. Which begs the questions, where's the storage solution? So it's finite. So this is why there needs to be, and there is, the transition to utilization technology. UKRI have actually written into their investment strategy that by 2025, every single investment decision will have sustainability at the heart. So it's really good to see we're getting there.
Brilliant. Chris, what was your question?
My question was to Martina. I'm ever so sorry, Martina, I had to duck out for a bit, so I missed the start of your presentation, but very interesting idea. I was interested in your production and how that compares with competitors, because there's a manufacturer of corn, I think, which I don't know if you've ever eaten it. You need to put quite a bit with it to make it taste of anything, but they presumably have a continuous process of manufacture of some sort there. So I'm just wondering, if you look at your competitors, whether there's anyone out there that could produce vast quantities and still meet that commercial requirement, but that might actually outperform what you're doing.
Very, very good question, Chris. With corn, again, we are talking about a plant-based again. So we are not talking about cultured meat or cultivated meat per se, which does use mammalian cells, so cells taken from animal. So that is not something that is commercially available at the moment, except, as I was mentioning, that restaurant in Singapore, where you have 1% of chicken cells into a plant-based scaffold. The companies that are working on cultured meat, they are using the scale-up technologies to expand the cells that are utilized in the biopharma industry. So we are talking about using bioreactors from, for example, Sartorius, GE, pulp. But of course, those reactors are producing lower amount of product that is a high value product that they can then sell for hundreds of thousands of pounds per gram or per kilogram. Okay, so we're talking about, in this case for cultured meat, the complete opposite. We need high amount of product that does actually have a lower value, because you cannot pretend to go to supermarket and to buy a cultured meat burger that costs £350,000, as it was the cost of the proof of concept that Mark Post made in 2013. Of course, the costs are going down, but we need all the enabling technologies to tackle each individual challenge, from having a medium that does not contain animal serum to grow the cells, which is one of the first challenges, the type of cells you use, the process to expand all these cells, and then as a final downstream process, how you combine all the cell mass together. So we really need a lot of enabling technologies because cultured meat companies some are trying to tackle all these challenges within their own company, so having a lot of teams working on all these different ones, and others are instead collaborating with companies like us that do provide enabling technologies to work together to find a solution. Most of them, they already know that if you don't think out of the box and if you don't invest on new type of technologies, using what is available at the moment is not going to be possible and not even economically viable. Sorry, I didn't get the word viable at the end. So, yeah.
Thanks, Martina. Just one other thing. The plant-based ones obviously use something growing, so they're taking CO2 in. How do yours compare? Does it take in CO2 in the same sort of levels as a plant-based one? I
am not really sure about the type of, what kind of scaffolds, what kind of, because there are different approaches on the plant-based, okay? For example, the corns we're talking about, fungi. In other cases, we might talking really about mixing together different vegetables and mixing them all together to create this kind of structure for cells to grow on. Some are even try to grow them on celery, for example. There are a lot of different approaches, and I don't know, because this is really, kind of downstream and out of our, I'm not really sure about in terms of, emissions or in terms of greenhouse gases, that particular part of the process stands in. Yeah.
Thanks ever so much, Martina. Thank you.
Thank you. Unfortunately, we have too many questions, so I'll quickly come to Tracy before the end of this event.
Thanks, James. Martina, I'm fascinated by all this, although I was slightly distracted by some recycling misinformation I'm trying to educate people on. I'm someone who's a vegetarian and I haven't really eaten meat for 30 years. So what Chris just said about corn was quite interesting. I'm very concerned that you said that despite all the people who are becoming vegetarians and vegans, that actually meat consumption is on the increase.
Yes, it is. There are a lot of reports, especially in countries that are developing, quite quickly during the recent years, talking about especially, for example, China and India.
Yep.
Is going definitely up. And these are actually the country where the population is growing even quicker. So you might see some change here,
Yep.
With a lot of new plant-based products that are hitting the supermarket, and I'm very happy about it to see that, and more people that are buying that, but this is not enough, unfortunately.
Okay, so what we're seeing in the Western world is not actually a reflection of the rest of the world. Okay, thank you.
I think, again, I know we gotta wrap up now, James, but I think that you just attacked an issue that we've got to realize. It's not just us, it's the whole world has to be working this net zero. It's not just the Western world. It's not just the developed world. We obviously have some great stuff that we have to do, but all of the entire world has to be brought in line with this, which is really a huge, huge undertaking that I think we all need to appreciate, and we all need to do everything we can to make it work. James, I think that pretty much wraps up our time here, and I'd like to thank everybody for attending, and I think it was a good discussion. So